Hello, students, and welcome back. Today, we're going to learn about how statistics are used in psychology. So there's really two different types of statistics that are used in psychology. The first one are descriptive statistics. So descriptive statistics are a summary of data that you can directly observe. So these are things you're probably familiar with, like mean and median, range, maybe less familiar with standard deviation, which we'll talk about in a moment. Inferential statistics is a method assessing the likelihood that something is going to happen in the future, like probability, or testing a sample of the population in order to generalize to the entire population. So inferential statistics uses a random sample of data taken from a population to describe and make inferences about the population. Inferential statistics are valuable when it's not convenient or possible to examine each member of an entire population. For example, it is impractical to measure the diameter of a nail that is manufactured in a mill, but you can measure the diameters of a representative random sample of nails and use that information to make generalizations about the diameters of all the nails that are produced. Measures of central tendency. Are you looking at one number to describe a population's income, height, age, etc.? The mean is the arithmetic average. The median is the middle or middle number. It's half above and half below. Also, keep in mind that if there's not a direct mean middle number, you take the two middle numbers, add them together, and divide by 2, and that gives you your median. The mode is the most common number. When would one option be better than another? So I like to use this image here to help illustrate the idea of the bell curve, which is a review from the last time we talked about this in intelligence testing. So what do you notice about this in terms of like weight? What is the most commonly used one and what are the least commonly used ones? The normal distribution. IQ tests use standardization, which is comparing the results to those who have taken the exam before. This gives you a normal curve. Remember, we're looking at the scores for intelligence tests. So most people, 68% of people, their scores fall within 85 and 115. On average, most people get around 100 for a score on their IQ test. And then what we're looking at is each standard deviation is 15 points above or below. So one standard deviation above would be 115, two standard deviations above the average would be 130, three standard deviations, 145, and so on and so forth. Remember that it's important to re-standardize tests due to the Flynn effect. So this is a review. So measures of central tendency. So here's the mode, median, and mean of a family income distribution. Note that this is a greatly skewed distribution. A few families greatly raise the mean score. Okay, so if we look at this data, if I said that the mean is $70,000 for this particular community, that would look pretty good. But is that actually what's going on here? No. What are most people actually making in this distribution? Okay, and then who's in the actual middle? Who's in the median? Why does this seesaw balance then? It balances because these two family groups, one making $475,000 and one making $710,000, are equal to all of the other people who are making this money. Here's a little bit more about skewed distributions. Measures of variance. How much does your data vary? So the range is the difference between the highest and lowest numbers in a distribution of numbers. Standard deviation is a calculation of the average distance of scores from the mean. It's important to note that the larger the standard deviation, the greater the spread, whereas the smaller the standard deviation, the smaller the spread. And what I mean by that is more of the scores are going to cluster towards the average than in a large standard deviation. So standard deviation tends to follow what's called the 68, 95, 99.7 rule. And what that means is 68% of all scores fall within one standard deviation, 95% of all scores fall within two standard deviations, and 99.7% fall within three standard deviations. So when we get into abnormality, we're really looking at anything in that 0.3%. That's what we consider, genius. So another way of visualizing this, if this helps you, how to calculate standard deviation. So first of all, don't get too overwhelmed with this. There's going to be an assignment for you to do for this. But Don't get intimidated, okay? So standard deviation and variance. So the standard deviation is a measure of how spread out the numbers are. The formula is easy. It is the square root of the variance. So you might ask, what is the variance? So the variance, which is the square of the standard deviation, is defined as the average of the squares difference from the mean. In other words, follow these steps. First, you got to work out the mean. Then for each number, subtract the mean and then square the result. This is the square difference. Then work out the average of those square differences. So let's put this into practice. You and your friends have just measured the heights of dogs in millimeters. Okay, and so we're going to measure the heights at the shoulders of the dogs. And you have found we have one dog which is 600 millimeters, one that's 470 millimeters, one that's 170, one that's 430, and one that's 300 millimeters. So find out the mean, the variance, and the standard deviation. So the first thing you're going to do is find the mean. So what is the mean? So you should have come up with a mean of 394. So the average height for all the dogs is 394. So let's plot this on that same chart. So that green line is the average. Now we're going to calculate each dog's difference from the mean. So I'd like for you to do that now. What is the difference of each dog's height from the mean? So what you're going to do is you're going to subtract 394 from 600, from 470, and so on and so forth. So you should get this. And it's okay to have some negative numbers. So to calculate the variance, we're going to take each difference and then square it. So you're going to take 206, you're going to square it. So this should give you 108,520. Then you're going to divide that by 5. So you're going to get 21,704. So this is the variance. So the standard deviation is the square of that. So the standard deviation in this case would be 147. So the good thing about standard deviation is that it's useful. So now you can show that heights are within one standard deviation of the mean. So why should you square? So squaring each difference makes them all positive numbers. This avoids negatives, which would reduce the variance. And it also makes the bigger differences stand out. But squaring them makes the final answer really big. So unsquaring the variance by taking the square root makes the standard deviation a much more useful number. Now that we've done some calculations with standard deviations, you'll have an assignment that you're going to work on your own. Applying standard deviation. So let's say I have two classes which recently received the following scores. Class A had an average score of 74% with a standard deviation of 3. Class B had an average of 77% with a standard deviation of 11%. What conclusions can we draw? Which class did better as a whole on the exam? Statistical significance, or the p-value. So how likely are your findings the result of chance? First of all, when we're talking about statistics in psychology, we start with the null hypothesis. The null hypothesis is the default position stating that there's no real difference between two variables. Statistical significance is a standard for deciding whether an observed difference is because of chance. So essentially what we have is the p-value, which has to be less than 0.05%. Now, another way of thinking about this is you're essentially saying that you're 95% sure that one thing is causing another, or that there's a relationship between these two variables. You're 95%. So anything below 95%, so like 94%, would not be statistically significant. So that's kind of the important thing to keep in mind here. So we're going to watch a few things about statistical significance now. And that, ladies and gentlemen, is all I have for you today. If you have any questions, let me know. Otherwise, have a fantastic day.